Welcome to Unit 5. This unit is about similarity and congruency between shapes. So let's work on the notes. Figures that are congruent have the same shape and the same size. So look at these rectangles. Are they congruent? Well, we can see that this rectangle is 6 units long, and this one is 3. So they are not congruent because they are not the same size. Are they similar? That's a really good question. To find similarity, you find the side lengths and see if they have the same ratio. You learned this back in Algebra 1. This is called a scale factor. Oops. Helps if I can spell. Scale factor. If you've ever built a model, you know a model it says 1:25. That means the model of your car is 1/25 the size of a real car. That's what a scale factor is. So to find the ratios, you make fractions of the corresponding sides and reduce them. So, corresponding sides, I will do these in red. This side is 2 units. This side is 1 unit. Okay, the side on the bottom, 2 units, and that is on the bottom. I'm just going to go B for bottom. And then look at the sides. This one is 6, and this one is 3. So this is S for sides. So if I reduce 6/3, it reduces to 2/1. Okay. So that means these ratios match. See, they're both 2/1. Since the ratios are the same, the rectangles must have the same shape and are similar. So get these two definitions. Congruent means same shape and size. Similar means same shape and the sides are in the same ratio, the same proportion. All right, so let's go answer these two questions. We're going to look at these. And this is how it's going to look in Alex. Okay, are these two triangles congruent? No, they are not. That's kind of obvious. Are they similar? We have to check. Do they have the same shape and the same size? Be a little bigger. Okay, this length is 1. This length is 3. So you've got 1/3. Okay, now let's look at the height. This is 1 and this is 1. The heights are 1/1. Are those equal? They are not. They are not in the same ratio, so these triangles are not similar. All right, now let's look at these two shapes. Thinking, oh boy, this is going to be tough. No, it's not. Are these congruent? No, they are definitely not congruent. Okay, now let's look at lengths. This length is 2. This is 1. This is 2. This is 1. 1, 2, 3, 4, 5. This is 6. This is 3. And this is 2. And so let's play around and see what we got. So you've got 1/2, right? These two. Then you've got 3 across, and I'm doing smaller over big. 3/6. Those two. And I've got, oh, look over here. I'll do a different color for, I'll do a different color. We've got 1/2 for those sides. So how are we doing so far? You know what all these add up to? These are all 1/2. The ratios are the same. Now, something extremely important when you're doing this. You have to keep the figure measurements on the same part. If you use a smaller figure on the numerator in one ratio, you must use the numerator in all of them. If you use the figure on the left in the numerator on the first ratio, you have to use the figure on the left as the numerator in all of them. You cannot mix and match. What you start off with as the figure in the numerator must stay that figure. That's where errors come in. All right, so make sure you are consistent. I'm going to write that on here. Keep figures in same place, same places in ratios, okay? That will help you eliminate an error. All right, so are these similar? Yes, these two figures are similar because they all have the same ratio. The ratio of each part of the small figure is the same to the larger figure. Okay, now ratios, if we know how two triangles are similar, let's check that one out. Let's put in some numbers. We are saying that A, B, and C, triangle ABC, and triangle PQR are similar. The length of the AB is 6. The length of PQ is 8. Now we're telling you these are similar. Remember what I've told you before. In geometry, you do not make any assumptions unless we tell you. Okay? So we can reduce this to, divided by 2, 3/4. You're looking for corresponding parts. So what is the corresponding side to BC? That is QR. And what is the length of BC? 18. And QR is 24. See how we're keeping triangle ABC in the numerator on each piece. All right, let's divide. Is the ratio the same? It should be. Divide by 6, because that's a common factor, and you get 3/4. Now, let's look at side AC. It's down here on the bottom. That is corresponding to side PR. AC is 15, PR is 20, common factor is 5, divide both parts by 5, and I get 3/4. All right, so I checked, circling all my final ratios. They didn't look the same, did they? But when you reduce them, they are. Are all corresponding side lengths in the same ratio? Yes, they are. Do you expect this from similar triangles? Well, remember what we did in the first page of notes? We said similar things are the same shape, but they are different scale, but each side is the same scale. Look at our proportions, our ratios here, excuse me. Ratio of AB to PQ is 3/4. The ratio of each side is 3/4. So yes, you expect side lengths in the same ratio when you're looking at triangles. All right, let's do next one is we ended up with notes split on 2 pages. So I'm going to write some, sorry guys, whoops, eraser. Okay, the problem on this page that didn't quite make it. So, all right, I'll make it nice and neat. All right. I'm going to write measure of angle A is, I'm taking this directly from the notes since, again, they split off into 2 pages. Sorry about that. All right, now I need to draw some triangles so you know what you're looking at. So let's do some triangles. Now, I apologize. You You know I can't draw. This is ABC. And this is DEF. And I've told you before, in geometry, you do not assume anything. All right, and we've got to figure out measure of angle C. All right, now you're going to be putting a few things together here, okay? You have two triangles, and I have told you before, mark things up. So A is 30, and B is 63. So how do I find the measure of angle C? What is the measure when you add up all the angles in a triangle? 180. So what is 30 plus 63? It is 93. So we do over here, teeny tiny little math. 180 minus 93. Yeah, is 87. So the measure of angle C, which we calculated, is 87 degrees. Now let's look at our small triangle, triangle DEF. You know I can't write the numbers there. Okay? So angle D is 31, angle E is 46. Together that's 77 degrees. We've got to find the measurement of angle F. So we do 180 minus 77, 3 is 103. You're wondering, why are we doing this? Well, we're going to find angle measures and side ratios to determine if two triangles are similar. Let's look at it logically. In the previous page, we showed that corresponding sides of triangles have the same ratio when they are similar. Let's see what we do about angles. Interesting. Okay. Looking at the angles, well, that's interesting. The angles don't have, do the corresponding angles have same angles? The same measurement? No, they don't. Interesting. All right, let's look, use the measuring tool in Alex. You're going to have a ruler, okay? It'll be there. So now, here are all the measures of the side lengths. We've got AB is 15. I'm going to write them down. AC is 13. I've told you before, mark up your drawings. BC is 7. And let's do a different color. Do black over here. DE is 5. DF is 4. And EF is 2. So now we have all the information. We have our angle measures over on the left side, upper left, measure of angles A, B, and C, and angles DEF. We have the length of all the sides. So we have our raw data. Now we're going to put it together. So let's fill in some numbers. The measure of side AB. AB is 15. And what is DE? Corresponding side, it is 5. And that equals 3 over 1. Okay? Side BC is 7. And side EF is 2. That equals 7 over 2. Interesting. AC is 13. And the measure of DF is 4. And that equals 13 over 4. You can't reduce it. So are these two triangles similar? And the answer is no. Why are they not? The ratios are not the same. And another answer is the scale factors are different. That's saying the same thing. Scale factors are different. And that takes care of day 1. So you learn the difference between similarity and congruency. Congruency, the same size and the same shape. Similarity, corresponding sides have the same ratio. It's like taking a small rectangle and a big rectangle. If the sides have the same ratio, the figures are similar.